recording. Okay. I'm going to start from scratch. So welcome everybody online and on site. I'm very, very proud to see the 10 of another School of AI session. And once more, we have had the honor to host a remarkable group of fellows from all around the world. And we have gained the trust and support of innovative businesses that understand the potential benefits of using AI in their operations and processes. PySchool was founded in 2017 with the ambition to provide a nurturing environment and expert support for individuals interested in pursuing professional careers in AI, to offer them opportunities for learning and to work hands-on with on real industry cases. In doing so, we also wanted to provide businesses and organizations with ways to integrate AI and help them solve and optimize some of their challenges. And not only concentrate on the technology needed to innovate and generate value and impact, but also on the creative and entrepreneurial aspects that help ideas become profitable and successful enterprises. PySchool is the educational offspring of PyCampus, which was founded by Marco and I in 2006. With PySchool, we wanted to provide mentoring and network to startups that apply AI in different fields of the industry. PyCampus keeps growing and the startups are hitting some big milestones. We are proud to support these initiatives and we'll continue to do our best to enhance the transformation of the future. So let's look at some of the latest achievements of the PyCampus venture. And I would like to invite Sébastien Bratière, our Director of AI here at PySchool, to present some of the amazing enterprises that we have.
Thank you. Thanks, Isa. Welcome again, everybody. I'm going to tell you a bit more about where you stand, though I see many familiar faces, and so I guess many already know where you are. But for those of you who are unsure, so let me say a few words about PyCampus. So PyCampus is our venture fund. We do seed investments, so that means we do small investments, relatively speaking, in the life cycle of a company, 50 to 500,000 euros, and we take equity in exchange for that 1 to 10%. The fund was founded by Marco and by Isa, as Isa said, a couple of years ago, and today, I heard from Marco a couple of days ago, we've got 56 investments, correct? Okay, and so I wanted to tell you about the latest ones. I did a couple of picks here to show you what's going on. They're really interesting, all of them. So they're all three from Y Combinator, the Winter 21 cohort. So this is Hubble Network. Hubble Network essentially is solving the problem of deployment of Bluetooth at global scale. It's kind of like the Starlink, but for Bluetooth. One of the problems that you have that comes with Bluetooth, especially Bluetooth low energy, is you want to deploy it, but you've got to deploy the infrastructure, terrestrial infrastructure that goes with that. And these guys have found remarkable technological solutions to solve this issue by deploying suborbital satellite constellations so that they can speak to devices, to BLE, Bluetooth low energy devices on the ground. And in doing so, solve, you can imagine, a host of problems in logistics, maintenance, environmental monitoring, and many other problem areas. So it's kind of like a very big problem solved by a single bit of very clever technology here. Another one is Toco Tutor. So Toco is the brainchild of two MIT graduates, Chinese MIT graduates, who have approached the problem that many language learners face, that they find themselves shy in front of their tutor, in front of their teacher, and they'd rather be in a more relaxed, more comfortable situation. So they've developed an entire platform to allow you to learn English speaking to a machine using, you can imagine, a ton of AI behind the scenes. So this is, it's a help to people who want to learn languages. They're deploying it for English. They're starting in China to start with, and they're, making it easy also from the point of view of logistics, like, trying to book a language teacher is not always that's easy to fit into your daily life. So doing that with a machine is both more relaxing from the psychological point of view, but also from the organizational one. This is Toco Tutor, and this is Strong Compute. So Strong Compute is another, I think, gem that Marco manages to find in these Y Combinator pitches, I think. Y Combinator, Strong Compute works on the problem of speeding up deep learning computations. One of the issues that come with, the industry of cloud compute is that essentially many cloud computing platforms essentially benefit from inefficiencies in your consumption schema. Let's face it. That means that the more inefficient you are, the more you consume, and therefore they make more money. So this is a kind of disalignment in incentives that Strong Compute is trying to tackle. And so the solution they offer is priced based on speed ups, not based on kind of volume or whatever you buy. And that means it's in their interest to speed up your deep learning workloads as much as possible. This has an added advantage, which is sort of very near to close to our heart at PyCampus and at Translated. We feel it in our flesh, I would say. And it's to do with talent. So you don't want to have highly paid deep learning developers waste time or become unmotivated because they need to wait for the results of their experiments or of their training and so forth. And sometimes these things effectively last for weeks. Okay, so it's not a matter of a couple of minutes that we're speaking of here. And one of the indeed pitch points that they make, and that I thought was indeed relevant to a lot of the industry here, is that by accelerating these kind of training experimental workloads, you make those developers happier and much more productive because they can iterate faster over their deep learning architectures. Okay, back to the PySchool of AI program that we're discussing the outcomes of today. We set up PySchool because we're attacking this pain that we saw in the AI industry, that many of the companies that were trying to reap benefits from AI weren't able to do so because of kind of like a twofold problem. One is that they find it hard to work on solutions because they can't access the right talent. And the other one is that in their starting steps, it's difficult for them to understand how to do experiments, how to prototype. And we, with the program that we have, we solve both of these issues at once. So we take business pain on the one side, we take the state of the art of AI and machine learning on the other side. We work on well-defined problems for a duration of 8 weeks, and then we deliver a prototype. The recipe works because we've got amazing, I would say, ingredients in this mix. We've got amazing fellows that are the people who are going to present the work they did, but also we've got amazing sponsors. And that means we've got people who've got business problems that they know can be solved with AI. They're lacking the solution, and we're here to work on that, but they know they have identified a business pain, and sometimes they also have identified a data set or collected a data set specifically for that problem, and we help them utilize that to solve the problem. And then we throw in another ingredient, which is excellence, specialty, expertise, and that comes from our mentors, both from inside and outside PySchool. That's where the state of the art comes from. We mix all this together, and we end up with these stories and these successes that our teams will tell you about in a second. Okay, without further ado, I'd like to introduce the first team then, and I'll pass the stage to Eric.
Thank you very much, Sebastian. My name is Erik Waldstoni, and I've been working with my partner Teresa over the past few weeks, scouting for investment targets alongside our stakeholder Ardian. Okay, sorry. So Ardian is a private equity firm, and their issue is financial forecasting. Here at PyCampus, we're trying to help them with the origination use case in order to transform and digitalize the private equity firm. Financial forecasting is an issue. It depends on the step where we are in the economic cycle, on the economic agreements that we have, natural disasters, as well as headlines, and of course, the financial features. What's the current situation? To do a very good forecast, we need to manually look through hundreds, if not thousands, of income statements and balance sheets. And nowadays, and as always, EBITDA has been a very good measure of success for the growth. Now, our task here is to find more features that are able to predict this financial growth with more accuracy than using a single metric. From the stakeholder, we received data. The data that we received is 10 years for over 500,000 companies. And our data set included 6,000 Italian companies with a mixed performance set. And of course, with all this data comes some limitations. There's hundreds of metrics per year per company, and of course, there's missing data. What's the objective with this? The objective is simple, is to find the well-performing companies, to be able to predict and forecast which companies are able to perform well tomorrow, the day after, and also next week. And what's the impact for this? We have a reduced investment risk. We're able to find new opportunities, as well as have an increased profit, not only for Ardian, but also all the stakeholders inside. So our task formulation was the following. Given our set of inputs, we'll transform the data and we'll choose specific features or financial metrics that we'll calculate, and we'll pre-process the data, scaling it, extracting the mixing values, as well as splitting it. Then we model this with some very naive methods, some baselines, and then we use a bit other strategies such as some classifiers and regressors. From here, we'll be able to evaluate and have a prediction. And our evaluation metric will be the root mean squared error. Over the past 8 weeks, our progress started with some very basic familiarization with the task. I do not come from a financial background, neither does my partner, so we had to get knees deep into this. Along the second weeks and the upcoming weeks, we did some baseline models. We modeled it in a time series type of way. We also modeled it in a regression way, and also tried classification, ultimately coming up to a feature selection and then evaluating all these models. What were our results? On this table, we see on the side the type of models that we used, and these are all regressors, which are the ones that performed the best. We see our naive prediction for revenue, and then we see our best models prediction for revenue. And these are, of course, in millions of euros for revenue. And for the other features, we have our naive prediction for employees, as well as the root mean squared error for employees. What can we see from this? We saw that using different features and different financial metrics, we're able to reduce the error and thus able to reduce the uncertainty for future investments. My name is Erik Waldstoni, and I'm a master's student at the Universitat Politècnica de Catalunya. I've been working in the pharmaceutical industry as well as in digital marketing, and my partner is a master in data and web engineering from Ethiopia, Teresa Bodajo. Thank you very much for your attention.
Hello, everyone. I'm Joao. I coach the team on this project, and I would like to say a couple of words. So first of all, thank you, Eric and Teresa, for the work you put up in the last couple of weeks. It was a pleasure to work with you guys. Afterwards, I would like to thank Ardian Growth for their fruitful discussions throughout the week, and also for their promptness into providing new data and helpful guidelines that allow the team to progress on the project. And then about the project itself, it's a difficult project because since we are forecasting and modeling financial metrics, it's very hard to predict certain aspects of it. There are, of course, always factors that we cannot model or predict in advance. And so this actually affects the results that the team could get. Nonetheless, in a short amount of time of 8 weeks, they managed to have a convincing solution that provided better results than simple baselines. So I think this is definitely a progress, and I believe that the project can still go forward and it can achieve better results with more time. Thank you. Off to Sinan. Sorry.
Thank you, Joao.
Yeah.
Hello, everybody. I'm here to present our work called AI for Accurate Tank Level Estimation in Rental Cars, sponsored by Octo. So the problem is car rental companies needs to know the refueling volume when the customers return the car back. But there is a bottleneck here. The bottleneck is the fuel gauges. The fuel gauges almost inaccurate, especially in the top of the tank. So for example, you took a car from the rental company and you drive a little bit, and then you spend a couple of liters in the trip. But the fuel gauge says the tank is still full, so that the rental companies cannot charge you for the missing fuel level. So here, our objective is starting from the fuel tank, and we drive a little bit. So we try to estimate the fuel level at the end of the trip, regardless of the car type and regardless of the tank level shape, because the tank shape also affecting the fuel level estimates. So we cannot do it manually because it's so expensive. So here ML comes to play. The rental car industry loses over $200 million in each year due to incorrect estimation of the fuel level, according to our stakeholder from Octo. And this number can go up. For example, a car rental company can lose up to $5 per each trip. So we have over 6 million cars in our world. So the number can go up to $30 million per each trip. So imagine that how many trips are made in a single day. Which is $1 billion industry. So the traditional solution that currently companies using is they're using a basic semiotic techniques. As you can see from the figure, the blue line represents the raw fuel level that coming from the devices that attach to the vehicle. So as you can see, the blue line is going up and down as the time passes, which is impossible because raw fuel level cannot go up as the time passes. So they end up with this orange line, which represents the smoothed version of the blue line. So, but this doesn't work either, because at the top and the bottom of the tank, you can observe that the error is still going. So the fuel gauge says still I'm full, or it still says I'm empty. In order to solve this challenge, we don't know any ground truth label. We just have these noisy estimates. And apart from that, we have a couple of features that comes from the device that are attached to the vehicle. For example, we have some vehicle speed, longitude, latitude, and where car is heading. So our solution proposed of 2 parts. The first part is we are taking the middle range of the data, because we know that the middle range has the lowest error compared to the top and the bottom of the tank. So we train our model using the middle range data and evaluate on it with whole data. And the other part is doing the opposite thing. So we are taking the top and the bottom of the tank, and we are training our model. And for the middle tank, we just trust our smoothing techniques, because we know that the smoothing techniques works well in the middle range of the data. So since we don't have any ground truth labels, how do we estimate this model? So we have to drive our ground truth. We are taking the raw noisy signals, we are smoothing it. For the labeling part, we start from the top of the tank. So we know that the car capacity, so we can refer to this. So we drive a little bit and we end up with the Tn, time Tn. So if we take the difference between these, we end up with the consumed fuel level. So we can compare it with, we try to minimize this loss coming from our prediction model and the consumed fuel. But the evaluation is a little bit tricky because we don't know, although we have a lot of data, we have a few cars that represents our situation. And we don't have that much diversity either. So in this challenge, the important part is estimating the full level, especially in the top of the tank. So the refueling events happen mid and the bottom of the tank. So it makes our lives difficult. So I am Sinan Gençoğlu, and my teams consist of Burhan, he's an ML scientist, and Lloyd is an ML and robotics engineer, and Hugh, AI and robotics engineer. So Octo is operating the car rental industry for years. They are experienced, and we are the best team to support them. So thanks Octo and our coach, Francesco. I'm leaving the floor to Francesco.
Thank you, Sinan, for the interesting presentation. I'll introduce myself. I'm Francesco. As Sinan said, I've been coaching this challenge for the past 8 weeks. And as you might have guessed, estimating correctly the exact fuel level in a tank is per se a challenging task for at least 2 reasons, right? The first one is inherent inaccuracies in sensor readings, as we saw, and but also for other kind of problems. For example, due to the fuel sloshing within the tank and causing inexact readings. Not only this, because other problems involve, for instance, deriving ground truth. So understanding the actual fuel level in the tank. You can imagine that it's painful to just empty the tank completely just to understand the exact fuel level that was in it. So props to the team, props to Sinan, Buran, Hugh, and Lloyd that came up with smart and interesting ideas to tackle these problems, to derive ground truth and evaluate their models and their predictions against the ground truth. Thank you. I would like to then leave the floor to the next presenter. Please, Nirzari.
Thank you, Francesco. Good evening, everyone. Thank you for being here. My name is Nirzari, and I'm here with another challenge from Octo. Yes. So Octo provides telematics solutions to car insurance companies. So obviously they are interested in metrics that can help them estimate the risk that is associated when a car is driving. So one of the metrics that we might think is a car trip distance, right? So the longer a car drives, the more the risks, certain risks that are associated with it, right? So you might say that in the age of navigation services, how is distance estimation a challenge in the first place? Well, it is, because people do not like to keep their GPS or location services on for privacy reasons and also for not draining their batteries, right? So the next best thing that we could do is use maybe another set of sensors that even if they cannot directly measure location, they can indirectly measure it. So come to our rescue, inertial measurement units, aka IMU, or motion sensors. So these comprise of accelerometers, gyroscopes, and sometimes a magnetometer. So we know from high school physics that acceleration can be integrated to get velocity, and velocity can be integrated to get displacement, right? So why wouldn't this work? Well, this wouldn't work because the signal that accelerometer contains is not just the acceleration of car in the forward axis, but it also contains data of vibrations that the car goes through when you are driving, right? So if you integrate this signal plus noise, you get this huge integration error, right? So now that we understand the problem, we would like to explain the solution space. So we approached this problem from two directions. One was physics-based solutions, and the other are data-driven solutions. So the physics-based thing is just integrate directly acceleration to get displacement. And the other set of approaches are data-driven ones, where we try to estimate the trip distance through indirect estimations. So let's go through the physics-based approach. So the first thing we need to do in this is, let's say you have oriented, so in this case, the phone is our sensor, and assuming this pointer is our phone. If you are driving in a certain axis and your phone is oriented in some way, we need to reorient this to get into the Earth's driving axis, axis. So the reason we need to do this is to remove the gravity away from the picture, because even if you are not accelerating, a g-force of 9.8 is always acting, right? So, and the thing is, even if we do rotation, we are still not yet out of all the error, right? Because that, as you see, that the blue signal, which is the integration of IMU, is always increasing, even if the ground truth is somewhere much lower, right? So what we did is we do filtering of this signal. So we applied bandpass filtering to get rid of some high frequency noise. And you see that now there is at least a much better match than earlier of the signals. So this is after the bandpass filtering. So the next set of approaches are the data-driven ones. And in this one, the first thing that we tried was, why don't we just get an estimate of the entire trip's average speeds, right? And then at inference time, just multiply it with trip duration. And the next thing we tried was, why don't we just remove the pauses away so that we only get the active time of the trip? And with this, we already got good results. So this model just has a single parameter, and with that, it has really promising results. What you see is the actual versus the estimated trip distances, and each dot is a trip. These are the mean absolute error and the mean absolute percentage error, which were our metrics that we were tracking all the time for all of the approaches, right? Further, this approach can be improved by clustering the trips, by trying to get some signatures of the trip by, for example, so what we did was we tried to estimate certain time series features from these acceleration signals and try to cluster them. And what we see is already the high speed trips can already be clustered away from the rest of them, right? And this is the future work for the speed-based approach, where we can get further clustering by getting IMU signatures for the trips. The last thing we tried was a machine learning model where we trained a CNN, and with the ground truth of GPS acceleration, we tried to mimic that from the IMU signals that we had. So these are our results for the three approaches that I discussed, and currently the average speed-based estimation trumps the others. However, each of these approaches have potential to be tuned further. So our final solution that we propose is, since each of these approaches are independent in the way they compute the distance, we could aggregate their estimates, and that aggregation would be much better than what these individual models give us. Our team comprises of Muhammad, who is an electrical engineer from Pakistan, and I'm Nirzari, a data scientist from India. And we had a great time working on this problem, and I would like to thank you for your attention.
Thank you, Nirzari. You might have guessed that trying to repurpose a smartphone as an accurate distance sensor is not really a simple thing to do, but props to the team for achieving that, and with great success. So why do I say this? Because smartphones, as you can imagine, and sensors contained within them are not really meant for this purpose, right? They're just meant for gaming interfaces. You're just trying to essentially figure out the orientation of your phone so that you can interact with whatever game you're playing. So instead, like I mentioned, Nirzari and Muhammad were able to repurpose these very naive sensors and turn them into modern and accurate distance sensors. So again, congratulations to the team. Now over to Irene for the next presentation. Thanks.
Thank you, Francesco. Hello. So I'd like to present our challenge, in which we analyzed the customer support call. So every company wants to know what are the problems of their clients. In order later to find a good solution and also address business strategies. Our sponsor, that is a big company with a call center, wants to know what is the issue of its client. So from one call, our sponsor wants to find the reason of contact, so why clients are contacting them. But it's really difficult because usually one call lasts about 5 minutes, and the ROC, so the reason of contact, the meaningful part of the call, is in only 20 seconds. Nowadays, most of the companies just know the sentiment of their clients, so if they are happy or not happy. But in this way, they are losing lots of information. They are missing the granularity of the problems of their clients. So going more in deep with our goal, we found that we needed tools for the ROC extraction, but to do that, we need a cleaner transcription and also to fine-tune the speech-to-text engine that our sponsor was using. So finally, manual transcripts to compute the word error rate that is a popular metric in this field. So we started with really noisy data. We wrote some guidelines and we managed a team of transcribers. And after that, we were able to compute the word error rate thanks to the GWare library that is implemented in Python. After that, we could improve the speech-to-text tool and finally to reach our goal using BERT topic. But let's go more in deep with what we did. So with the guidelines here, you can see some of them. So for example, writing numbers using digits and not words, or for the word error rate, we have two transcriptions, one that is made by the speech-to-text tool and one by humans. So we found a number that is the word error rate between them. And for the technical part, we used BERT, that is a language model. And after that, we trained BERT on the sponsor data. So we were able to get a better model. And finally, we were able to reach to a customized sentence BERT. So giving as input the conversations to the customized sentence BERT and later applying BERT topic, we found multiple topics on top of which we were able to find the reason of contact. So here we can see the pipeline. With a new call, we transform that in text, and then we have too many ways to go on. The first one is to summarize the call by leveraging GPT-3 tool, and the second one is to find the reason of contact with our model. We are the best team to do that because it is composed by Marcello, a computer scientist that daily works with big data, and also at ESA. And so then we have Michela, a computer engineer that is passionate about languages and really good at coding. Me, I have a maths and data science background, and also I like solving problems. And we would like also to thank our mentors, Federico and David, that are NLP experts. And also thank you very much for the attention.
Thank you, Irene. Beautiful. I wasn't the coach for this challenge, but I'm covering for Cristiano De Nobili, who indeed coached that one team and another one. Cristiano is in Brussels today. He was invited to an event for young AI professionals. So you've seen a ton of things here. And indeed, this challenge was very full. So Irene mentioned the two tasks that we worked on. One to do with transcription to improve a speech text engine. The other one to do with the actual thing that has business value, i.e. reason of call extraction. So for the first one, we partnered, obviously, with Nextdoors. We partnered with Translated with the professional linguists that we have in Translated. And these are the people who actually worked on doing the transcriptions, and we managed the protocols, the ways in which these things were done. The team worked on computing this word error rate, and I can tell you it's not totally trivial how this is, computed to align with how a human would compare two transcriptions. So there's been work in there. And I wanted to point out an extra kind of characteristic of this project. It's been a while now that in Pace School we've been trying to check out on NLP projects, especially natural language processing projects, what we could get out of the newest and strongest piece of general purpose technology for these problems. And so this is one reason why here we tried out solutions that could be obtained with this huge language model GPT-3. Some of you might have heard of that. This is a tool. It's a very powerful tool that wasn't available, I would say, 6 months ago. So we're experimenting with these things to see what gives. In some of the challenges, we found out it works really well, and this was one such case. In other challenges, we found out we couldn't get any results out of it. We're keeping an eye on this because we see that this is like certainly the future of language modeling and the future of NLP to a great extent. So GPT-3 is a tool where you can write down a natural language description of a task, give a few examples of how the task is performed, and this is called few-shot learning. And then you just, hit generate or hit enter, and that tool digests the natural language description that you've given of that task and gives you an answer, which is quite amazing if you ask me, And so what Irene showed on this slide is that in this specific case, we were pleasantly surprised to see that this tool can produce very, I would say, surprisingly accurate summaries of entire customer calls. Okay, so it reads in the text, the transcription of the customer call, and produces this summary, which can then, you can imagine, which can then be used by the next operator who picks up a call from the same customer and so forth. So this was really interesting on this challenge. And while I'm on stage, I'm going to stay. I'm covering also for another team who worked on language identification. This is a challenge that we got from Translated, from our work at Translated. So I'm going to say a few words, probably not going to do justice to the efforts that they put in, but I'll try and give you an idea of what this is about. So the issue with, why do we do language identification? At Translated, we've got a series of use cases that mean that we need to understand what language has a specific string of text been written in, and initially we don't know. So this is especially the case for user-generated content, where we receive something that's been written by, maybe a customer of some large company, in chats, in customer support calls, in a comment. We don't know initially, despite their browser setting and everything, so we're not sure about the language that they're writing in. And obviously, if we need to do downstream language processing, such as machine translation, for instance, or human translation, we need to know what is the language that this has been written in. Another use case is we've been working with speech synthesis at Translated, and one issue that speech synthesis runs into typically, it's language specific. And so when it runs into a foreign word within, an English word, maybe in an Italian text, then by default, it will just try and pronounce it a la Italian. And you'd want to detect that this is English, and you should run it through a different text-to-speech engine to produce better quality. There's another use case, which is you get legacy data, and in many sort of industry settings, language data has not been tagged as to its actual language. So there's no thing that says, you know, FR or ENGB and stuff. And so you want to detect what language this is in. And then the last one, in very practical terms, in our QA process, when we deliver a translation to a customer, when they request a specific language variant, so this would be, for instance, Spanish from South America versus Spanish from like Castilian Spanish from Spain, then we need to make sure that what we deliver is in the right language variant. Okay. In our cases, this is done by language specialists, but this, you might imagine, is complicated, error-prone, and so forth. So there's all these reasons why we want to detect these things. You might say, rightly, there are very many existing solutions to do language identification, sort of standard, the vanilla version of this, and you're right. There are so many libraries and also cloud APIs. We see cloud APIs, volume, you pay per volume and stuff. It's got its own challenges. They've got shortcomings, however, and this is what we've been working on in this challenge. One is they don't support language variants very well. And the second one is when you pass them something that is shorter than a document, a page, or even a paragraph, performance decreases very sharply. It's very difficult for these engines to detect the language of short pieces of text. And this is what we've been working on. So language variant identification and sentence and word level language ID. I'm gonna point out some of the issues that we've been working on here. So to do the prediction of variants, these are examples of the features that need to be taken into consideration, the linguistic features. So in order to distinguish, for instance, English from the UK and English from the US, you need to look at features that many are related to spelling, but then word choice, and also some grammar rules are different between American English and British English. The same goes, with variants. When you try and distinguish different variants of French from France, from Canada, from Belgium, from Switzerland, and so forth, Swiss German and German spoken in Germany. And this is an example of Spanish spoken in Mexico and Castilian Spanish. So there are very many language phenomena at play that you need to model here. Another issue that we found out in the course of this challenge is data. So initially we thought there was no problem with data because at Translator we've got all this carefully tagged language data. And obviously, yes, we've got millions of examples of this, but then the next step, you run into the next issue when you do things, you try and fine tune things, you get to some level of performance and you want to climb that, then you figure out that there are many cases in which there's noise in your labels. So that means a language document actually contains strings which might be in mixed language. And when this is not an issue for a human translator, usually, because it might be just one sentence or a couple of words, obviously it's wrongly labeled data to an algorithm, and that's where the issues start. And then another issue that we found happens is that sometimes strings that we work on actually are totally ambiguous, even for a human. So you have strings like bonanza sweet, okay? What language is this in? The way I pronounce it, you might guess it's English, but it contains bonanza. Is it Spanish? Is it Italian? Any variant of that you might imagine contains foreign words, contains a couple of English words, you're not really sure. And so these are the kind of issues that we needed to deal with. And one way we tried to solve this one, it's by I would say a classic, a classic in terms of machine learning solutions. It's by producing synthetic data that we were sure of the labeling. So this is the synthetic data approach. And so here are a couple of techniques that we applied to produce these synthetic data sets. The team that worked on this, it's Tassin, who's a computer scientist and double Google Summer of Code awardee. So she worked on TensorFlow, on a project on TensorFlow. Many of you know TensorFlow. She worked on developing ULM fit for TensorFlow back at the time when that was kind of like pre-birth almost, ULM-FIT was one of the most promising paradigms to do fine-tuning, to do language model fine-tuning with little data. And Joseph is a master's graduate of the African Institute of Mathematical Sciences, which is an excellence institute in Africa that has different branches all over Africa, and tries and produce the next generation of machine learning engineers for Africa. So kudos to them. Thank you. Thank you. I'm sure they're watching, so they'll appreciate it, I'm sure. Okay, and with that, I'd like to pass on to Joao to tell us about medical seminars.
Thank you, Sebastian. So yes, I'd like to tell you what we've been doing, Stefano and I, over the last 8 weeks with AI-enhanced medical events. To kick it off, please say hello to Maria. She's a recent specialist in oncology here in Italy, and she knows as much as anybody that medical knowledge helps to save lives and to make quality of life for her patients better. To that effect, she signs up for the IOM 2022 conference. Now, AIOM conference has several thousand attendees, hundreds of papers that are presented. So when she goes to the conference, it's information overload. There's just too much, and she has to figure out what is the most important things that have been presented at the conference, and what is relevant to her use and her patients. Now, for the most part, up until now, conferences, what they have done is one of three things. Let's see. So the good ones will have a team of medical experts generate a conference output. This is both slow and, of course, expensive. The bad side is, yes, we'll send you a 200-page abstract book. You have nothing better than the table of contents to figure it out. The ugly, well, we just don't send you anything. So you go home and you scratch your head. So clearly there must be a market opportunity for enhancing these seminars with AI. Together with our sponsor, stakeholder, we have given a rough estimate around 3.6 million per annum in the organization of enhancing with AI. Furthermore, let us tell you the solution that we have come up with. Oops, what did I do? How do I put this back? Cheers. Thank you, Sebastian. So, meet our friend Bert. Don't be fooled by his looks. He's actually a very state-of-the-art transformer model in natural language processing. And what we have created is a tool, a suite of knowledge extraction tools, such as the ones you see here. And I'll do a deeper dive into the topic modeling and the question answering tools that we've built. So topic modeling helps cut through the clutter. Here, Maria can look at this topic model and see the different types of cancer. You see those at the bottom. Those are more the bog standard cancer diseases. Whereas if you look at the top, those are the KRAS and the BRCA1/2, which are very important mutations which affect a lot of patients and therefore the quality of life for them and the treatment. We go to the next one. I'll explain about after reading some of these articles, she has questions. So we built a question answering tool for that. So taking the material that was presented at IOM, we put that into a document store, which sends to retriever, which embeds all the documents. And then she can ask a question. She read about a certain drug called selpercatinib, and she wants to know how effective it is. So it puts it through the model. The retriever gives us the top 10 documents, and then the reader side of the model will look at the top 10 passages and offer us a reply, or offer Maria a reply, that is. So we bring it all together. This is a tool set that works harmoniously, whereby the result of a question answering can be put into the biomedical entities or into the topic model, and vice versa. Therefore, allowing both the researchers who are commissioned by the IOM organizer, or a physician such as Maria, to gain a better understanding of what has happened at the conference. The dream team who built this, well, Stefano over there, he brings an engineer's problem-solving attitude, and he is now an expert in NLP. Myself, I'm a data scientist, I've been an entrepreneur, and I have a chemical background, so helping to bring it all together, both the science and the business. So I want to thank you all for listening to us. I will pass it on to Francesco.
Thank you, Joao, and congratulations again to you and Stefano for the good work. So as you can imagine, and also as Joao already mentioned, the material that comes out from medical conferences is huge. It's huge in size, and comes in a variety of forms. So we can safely say, I would assume that even just extracting value and extracting meaningful information from this huge variety of documents and outputs is itself a challenge within the actual challenge. So props to the team again. Also, you saw that the team has prepared a set of tools to extract information from these materials. And I believe that this is exactly spot on because, like I said, you can look at this vast amount of information from several points of view. And I think producing different tools for different objectives, I think is the right thing to do. And I believe that the team did an excellent job in this. Thank you again. And I will leave the floor to Luigi for what I believe is the last presentation. Thank you.
Thank you, Francesco. It's always very difficult to be the last speaker between you and the buffet. So I'll try to be as quick as possible. So my name is Luigi, and today I want to talk with you about the journey that we did together with Neural Jam. So a few lucky people among us have a very clear idea of what are their values, their interests in life, and which are the profession where they can apply them at their best. Unfortunately, this is not the solution, not the situation for many of us. There are a lot of people with very little self-awareness. They don't have clear in mind what is their values, their interests, and they have very little information about the profession that could have helped them to exploit their interests and their values at their best. So, and this is a problem also from a company point of view. A lot of companies have issues in attracting and retaining talent and also getting the best out of their employees. So to make sure that, what the work that the employees deliver is up to the mark and is actually delivering value to the company. So there are several tools that can help on this, like personality tests or asking friends and word of mouth, but we find out that they are not up to the task in most cases. So what we did together with Neural Jam is to help them build a new tool they are taking on, is then called the Intelligent Pathfinder, or IPF in short, which is a profiling tool that helps take out and formalize what are your values, your interests, and your work styles. And we combine them with a map of profession to try to find what is the profession group which is more suitable for your interests and values, and in which you can express you at your best, and also provide you a list of skills that you need to harness in order to succeed in those professions. So how did they do that? Well, we started 8 weeks ago from a blank piece of paper. We had absolutely no idea about this field or what are the values and that can be connected to some profession. So we spent the first 2 weeks aligning with our sponsor and try to find the ideal data source. So we find a very high quality data source with a data set with about 1,000 professions over about 100 metrics, including values, skills, and styles that helped us to connect the profiles and the profession. I mean, that wasn't so smooth because the data coming from the IPF profiling tool was not on the same scale or from the profession DB. So we tried a set of approach and metrics in order to calculate similarities between profession and profiles. And in the end, we settled on the cosine similarity. So we matched the profile of the person coming with the cluster that was closer to him from us. Let's call it an embedding point of view. And we provide them a set of suggestions, both on the general profession, also on the cluster made out of all the profession, and providing them an outlook about if this, if this particular set of profession was growing or was large. But we also selected a set of, we call top profession. So the profession that are supposed to grow the most over the next 10 years, and provide them also a list of skills needed to succeed specifically in those. And then in the last 2 weeks, we created a demo using state-of-the-art architecture with AWS and Nginx for the infrastructure, and FastAPI, scikit-learn, and Pandas in order to get the data, elaborate them, and present, let's say, a JSON with all the information back to the application of Neural Jam in order to include this tool into their, let's say, into their workflow when they present the profile to the user. This is helping, let's say, a market in which over 6 million people are taking personality tests every year, and about 90% of Fortune 500 companies and a lot of medium-sized ones are using this kind of profiling tool for their, let's say, hiring or yearly evaluation processes. And this market is growing 15% year over year. We are the best team to take on this challenge because Jamshid Alamoudi, which, by the way, was also one of the founders of pCampus, has spent over 20 years of his professional life helping people to grow in their professional and personal career. And so he has a deep expertise on this field. And me and Serdar, so besides sharing the same haircut, we also share a common pattern that we start working in a different field, like in finance or in sales, before turning back and going to the data science world. So we exactly know what it means to work in a field which is not the one that is suitable for you. Thank you very much.
Thank you, Luigi. So yeah, speaking of eating your own dog food, I think this is a very good example. You know, Jamshid as the co-founder of PySchool, you know, going on to new ventures, founding Neural Jam now, and coming back to PySchool, you know, to do a project with us. A difficult one at that. So one where you have seen there's this mix of you know, expert-driven content, things that come out of the expertise, and in this case here of Robert Weiss, who's a professor of behavioral psychology at the university and a specialist of change management and leadership and emotional intelligence and these things. So he's one of the designers of these questionnaires, and he's able to sort of do the link, you know, based on expert knowledge between the questions and the answers in these questionnaires and skills, interests, and values of people. And then what we wanted to do, you know, what the purpose of this IPF tool is to connect this back to professions. And that's where you need, you know, statistics about how these things connect, you know, both ways. So this project is a very good example of, you know, where you need to mix expert-driven information, expert-driven knowledge with data-driven information sources. This was also a challenge number 76 of PySchool, closing session number 10. So we now have a community of alumni that is about 180 people strong. You know, quite some volume here. A big community of people. You know, started in 2017. So our oldest alumni, you know, are now well advanced in their career in machine learning. Quite a few opportunities that arise from just networking and the effects of community, social dynamics, and so forth. So it's very satisfying to see these things develop. So I'll hand over to Maite to say a couple of goodbye words. Maite, you're still with us, I know.
I know, I'm here. I've been keeping company to the people joining us online. So thank you, Seb. I just want to say that the fellows' approaches to the problems and their solutions never cease to amaze me. So congratulations to all of you for achieving such incredible results with your projects. And thank you to all the companies that were involved with their challenges. A big thank you also to the mentors who assessed and advised the teams, Federico Bolensky, David Preti, and Fabio Fumarola. Thank you so much. And to the fellows, you are now part of the PySchool family. We wish you great success. We will always be here to further support you in your professional careers. Last but not least, I would like to thank the PySchool team, my PySchool team. Everyone here plays an important part in making this happen, and it's an absolute pleasure to work with you. So thank you, Isabel, Sebastian, Andrea, Cristiano, Joao, Francesco, Lucia, and Elena. And the last thing I'd like to say is that we'll be back. We have the next session of the School of AI scheduled already for August 22nd. So if you're interested in participating as a fellow, or you would like to sponsor a challenge, do let us know. We will be happy to discuss and study the possibilities. So this is it for session 10 of the School of AI. Thank you everyone for watching. Have a lovely evening, and we look forward to seeing you again in the fall for the next pitch day. So thank you and goodbye, everyone. Thank you everyone joining online. Goodbye.